Hello everyone, and welcome back to my channel. This is Vishu Anjipudi, and I am glad that you are here. Today, we'll be solving the 2017 AMC 8, problems 10 through 12. Problem 10. A box contains 5 cards, numbered 1, 2, 3, 4, and 5. These 3 cards are selected randomly without replacement from the box. What is the probability that 4 is the largest value selected? To do this, we have to decompose the desired condition. The probability that 4 is largest would mean 2 things. 4 is picked, and no number larger than 4 is picked. So this is going to be equal to the probability that there is no number larger than 4. And since 5 is the only number larger than 4, this is just probability of no 5. Then we multiply the probability of no 5 by the probability that 4 is in it. The problem with this approach is that these cases are not mutually exclusive. If there isn't any 5, there's a higher chance that 4 is selected. Because of this, we need to do casework in order to find the number of successes and number of failures using this framework. So we know that the total number of ways to choose 3 cards without replacement is just 5 choose 3, since order doesn't matter when comparing values. This is simply equal to 10. Now, we look at the number of ways that 4 is the largest value selected. So we do this by the largest value. So since 4 is the largest value, we put it at the left. Now, we can have a 3, 1, or a 4, 3, 2, 4, 2, 1. This is 3 ways. Thus, successes is equal to 3, and the probability is equal to successes divided by total, which is just 3 divided by 10. Choice C. Problem 11. A square-shaped floor is covered with congruent square tiles. If the total number of tiles that lie on the 2 diagonals is 37, how many tiles cover the floor? Let's first draw a diagram. So here is the large floor. Just drawing it out. It's a square. And here is the diagonal in red. And the smaller tiles will be represented by blue. So we have this tile. And the only relevant tiles are going to be the ones that are on the diagonal. So there's this one, dot, 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 for all the random space in between. Then from this side we have this one and this one. So how do we find the total number of tiles on the 2 diagonals? Well, as you can see in this diagram here, the squares on the diagonal are perfectly centered on the diagonal. In other words, the little squares' diagonals are on the larger square's diagonal. This means that in order for the total number of tiles that lie on the 2 diagonals to be 37, we need to have that the sum of the total number of squares on both diagonals. Note that this is not the only diagonal that there's squares that could be on. This diagonal also gives possible squares, right here. And don't forget that there's this middle square, and that intersects both. But basically, the total number of squares is going to be 2 times the number of squares on one diagonal, which is just the side length of the small square. I'll denote as S, so S is equal to small square side 2 times S divided by capital S, which is going to be a big square side minus 1. Actually, it's going to be capital S over little s because that's how many little squares can actually straddle the diagonal. So it's big S divided by little s. Okay. So that's going to be equal to 37. So we know that big S divided by little s is equal to 37 plus 1 over 2, 38 over 2, 19. This means that since the ratio of their side lengths is 19, the ratio of their areas is 19 squared, which is equal to 361. This means that 361 tiles cover the floor. Choice C. Problem 12. The smallest positive integer greater than 1 that leaves a remainder of 1 when divided by 4, 5, and 6 lies between which of the following pairs of numbers? We're given choices 2 and 19, 20 and 39, 40 and 59, 60 and 79, and 80 and 124. Well, first of all, we know that any number that has a remainder of 1 when divided by 4 can be expressed as 4x1 plus 1. And let's denote this number as n. Similarly, we also have that n is equal to 5x2 plus 1, since n also has a remainder of 1 when divided by 5. And again, x1 and x2 are constants. Finally, we have n is equal to 6 times x sub 3, where x sub 3 is, again, a constant, plus 1. So, now that we know that n can be expressed in these ways, we look at n minus 1. We have n minus 1 is equal to 4 x sub 1 plus and equals 5 x sub 2, and it's also equal to 6 x sub 3. This just means that n minus 1 is a multiple of the least common multiple of 4, 5, and 6. So we'll have this be k times the least common multiple of 4, 5, 6. And this least common multiple is just 30, because 30 is divisible by 4 and 5 and 6 and 60. So since 60 is divisible by 4, 5, and 6, we know that n minus 1 is equal to 60k. Thus, n is equal to 60k plus 1. Meaning that the smallest positive integer greater than 1 occurs when k equals 1, or n is just equal to 60 plus 1, or 61. 61 is between 60 and 79. So our answer is choice D, and we are done. Thank you so much for watching this video. It really means a lot. Please don't forget to like, share, and subscribe, as well as click the bell icon. As always, if you have any questions, comments, or concerns, please post them down below or email me at caspirations@gmail.com. This is Vishnu Anjipudi signing off. Bye.